afterwards, after the notes.
Yeah.
British train guy, TikTok.
It smells.
Today is the 21st. Ay, ay, ay. 10, 21. Did you see it?
Yeah.
Yeah, that was weird. We are going to call this function composition. This will become substantially more difficult when there are fractions involved. Today's functions are all linears and quadratics with no fractions. It's a very pleasant process. That statement is the truthfulness of that is predicated on the assumption that you can do basic algebra. So let's get to it. So here's what it means to compose two functions. So you take a function like this one. This is our first example, f of x is equal to 3x minus 2. And we have another function named g of x, how creative. And he is x squared minus 2x plus 5. Now, I know that if I asked you guys to just evaluate one of those functions, you'd have no troubles at all. Like if I said, hey, help me out and find me like f of 10, you'd know that that means to put 10 in place of x in the function named f, right? You know how to generally evaluate a function. But what we're going to do today is compose two functions with one another. And the way it's going to look is, and I think I started you with the easy one. Yes, I did. So here comes math problem number 1. Get used to this because this becomes a really critical component. After this, our next step is to start graphing functions and then graphing their inverses. And then also we're going to start taking and proving that two functions are inverses. And the way you can prove that two functions are inverses is by composing them with each other in both directions and verifying that something magical happens. I know, right? I figured that would probably come up. That is a little tiny circle. This is not the notation that I like to use. In fact, the only reason it's making its way into your notes today is because you'll be working in Delta Math, and this is the notation that the Delta Math people elected to use. So I wanted to show you the way I would write this problem down. By the way, if you say this out loud, it says f of g of x. The way I write it, and the way I think a decent percentage of math people write it is like this: f of g of x. That notation feels cleaner to me, and it's my preferred, but I don't have control over Delta Math. And so when you're doing problems today, that's not the letter O. It's a little raised circle. It's a very small circle raised, and it does look like the word fog. I get that. But that stands for f of g of x. So this is a composition in which we're going to compose f with g, and here's what it looks like. So the function on the outside, here's how you can do this. The function on the outside is named f. So what I'm going to do is I'm going to take the function named f, and I'm going to write it down. When I do that, I'm going to leave a space when I get to x. Remember, with functions, x is just an independent variable. It's an input. Functions are just little machines waiting to be fed. So the function f says feed me. And so what I do is I take out his input slot x and I leave a space. And in this case, normally, if this were a simple situation, I would just put a number in there, like 2 or -5, whatever I wanted to know. But in this case, I'm actually composing f I'm not evaluating at a number, I'm evaluating it at g of x. So now what we're going to do is we're going to take this entire yellow box and we're going to put it into the function, and it's going to look like this. There's absolutely no huge aha revelation moment in today's lesson. Today's lesson is merely a practice in mechanics. So this is what f of g of x looks like. I took the function named f and I fed into it g of x, and now we work it out. We simplify. And so you're going to, of course, distribute. So you're going to get 3x squared minus 6x plus 13. And so this is what your answer is right here. Yeah, 3, 5, 15 minus 2. Just jump that, skipped right ahead. Good. You okay? That's a very simple composition. Now, I'd be lying if I said that it was always that easy. Compositions work both ways. So that's the simple version, and every problem has a simple version and a hard version. So now we have to do it the other way. Any questions about f of g? Okay, now we're going to go the other direction. It's a much, all right, so it's a more unpleasant process when we go the other way. So we're going to this time compose g of f of x. So the reason this one's harder is because the function that's receiving the input is the quadratic function. And so we're going to have to do some pretty decent solid algebra 1 skills here. So I'm going to start with the function that is named first, in this case, g. The one you say first is the one that you sort of write down and take out his x's and put in just like a skeletal sort of void. So we're going to have the function g of x is blank squared minus 2 blank plus 5. And I mean, I'll color code this for you because I'm nice like that. But in case you're at all confused, these two things that I'm underlining in green were the input slots, and that's why they became these empty slots. Good. So blank squared minus 2 blank plus 5. What's going to go into those input slots? Right. And this is a bit of a nightmare for someone who struggles with basics. And so, you know, the first one is the real deal. The second one is just easy distribution, but the first one, I'll circle it for you in red. This one is the grade killer right here. What's our inclination? Like, what would we generally want to do, unfortunately, when someone says to do 3x minus 2 squared? Yeah, like a lot of people write this, and I'll just tell you, this is the most ghetto answer you can give me. So don't put yourself on the list of people that ever puts this. Some people say, oh, this is easy. I'll just square 3x and get 9x squared. And then, oh, how cute. I'll just square -2 and get 4. Don't be that kid. Got it? Don't be that kid. Because what's happening here is we're totally disrespecting the entire, you guys might remember the words square, square, multiply, double. You've heard them come out of my mouth quite a bit. How do we actually do the red problem? Yeah, that's right. Good. So when we do this 3x minus 2 squared, and I'll just refresh you on this since it's been a while. But this 3x minus 2 squared, remember, looks like this. And I generally won't go through the full 4-step process with you, but remember what it boils down to is square, square, multiply, double. So yes, if we do 3x and 3x, we get, yay, 9x squared. And yes, if we do -2 and -2, yay, we get +4. But again, where we're sort of flipping the math gods the bird, if we stop there, is in completely disregarding these two right here. What's that going to give us? What do the two in the middle make? -6x. And what do the two on the outside make? Add them together. Nice. So, I mean, I don't think for a second that that's something that's hard. I just know that from my experience that you square a binomial, and sometimes people say some pretty silly things. So that takes the place of the 3x minus 2 squared. And then the rest, like I said, is pretty easy. We're just going to the next half going to get what? What's this answer going to be right here? Yellow guy.
-6x plus 5.
Nice. And then from here, it's really just a matter of simplifying, right? Combine any like terms that you have. If there were any more parentheses laying around, get rid of them. But in this case, it just cleans up to 9x squared. And then what? Minus 18x. And then what? Plus 13. Did someone say 19? 13. Oh, 13. Thank God. I'm sorry. I thought you said 19. Yes, that's it. Done. So that's how you do a composition. And again, one way is easier than the other way. When you feed a quadratic into another one, it's easier. But when you feed another into a quadratic, there's just that one step that can kick your butt. So let's do one more. All right. So our functions on this one are f of x. And of course, why not g of x? And the function f is take two x squareds minus 3x's minus 11, and then g of x is negative 5x plus 1. Which is going to be the easier composition. Nice, good observation. So let's get the easy one out of the way first. So we're going to first do g of f of x. Again, as you say it out loud, again, the first one you say is the one that you're filling in. So I'm going to take the function named g, and I'm going to write it out. But when I get to where it says x, I'm just going to leave a blank. And that's not a large enough blank, I don't think. So I'm going to scoot this over a little bit like this. And what's going to go in the blank? Right. All of the other function is going in. So 2x squared minus 3x minus 11. This one's easy because it involves no squaring or anything. It's really just, I mean, give me a break. So when you distribute through, what do you get? That's 56. Done. Good, good. All right, let's do the harder one, and then I'll get out of your way and let you work. So the harder is going to be f of g. So f of g of x, since the quadratic is the first one. And there's probably a name for that in math. And it's not called the first one. There's probably a masterfully cool name, but I don't know what it is. So we're going to take f of x and we're going to copy it down. We're going to put 2 blank squared minus 3 blanks minus 11. And what's going in the blanks? Good job. So the other function goes in. So negative 5x plus 1. Voila. Order of operations kicks in. What do we have to do first? Yeah. Yeah, like there's a whole bunch of stuff that really just has to wait its dang turn, but anything that's in this yellow cloud is our priority, right? Nothing else can go. So real quick, what's that yellow cloud going to equal? No, try that again. 25x squared. What else? At the end is definitely plus 1, and in the middle, minus 10x. And if, you know, it would be the same conversation I had with you in the last class that we shared together. And if you wanted to know where the minus 10x came from, my answer will always be this. Take the red guy, take the green guy, and multiply them together, and then double whatever you get. That's how you fill in the middle. So great. And then remember that there's still a 2 lurking in front. So we have to put all of this in parentheses because the lurking 2 is still a distributor. And then while we're here, we might as well do this other distribution, this red distribution. Like while we're here, what do we get? Yeah. -3. And you could put the -3 and the -11 together, like while you're here kind of thing, or it doesn't matter. No hurry, because we got other stuff to do anyways. So from here now, it's just a matter of clean house, simplify, distribute, combine terms. How many x squareds do we get? So we get 50 of those bad boys. How many x's? Good. And I'm just going to put negative 5x because I realize at this point in my life that there's a negative 20x, but there's also a plus 15x waiting, lurking, right? Just get it done while you're there. And then what's 2 times 1? But again, you might as well put it all together unless you want things to make it take as long as you want, show as many steps as you want. But like in this case, I know that 2 minus 3 is -1, minus 11 is -12. Might as well just jump right to it and presto. That is it. So when it gets harder, and that concludes the lecture, FYI, I just thought I'd show you kind of what's coming down the pike, is that eventually we're going to have functions like 1 over x minus 3 would be one function, and then another function might be like x over x minus 4. Composing those with each other is quite a step up. But we're not ready for that because we don't really have a need for that yet. So good. All right, your assignment is on the delta math. Some of them will be the good compositions and some of them will be bad. It's luck of the draw. You might get 8 easy ones in a row. 8 easy. And then the person next to you is like, I keep getting the hard ones. It's like, well, boo-hoo.
Yeah.
You know, luck of the draw.